right, here is our objective. Coulomb's law deals with electrostatic forces and the magnitude of them when they are either repulsive or attractive. It also is a way to calculate how strong that calculation will be, or that attraction will be, rather. And it states their uh, their relationships, meaning like when they vary, what happens to the overall attractive or repulsive force. All right. So here is the law. All right. And the law doesn't explain why there are more attraction or repulsive forces. It just basically understanding the law will allow you to know that when these things change, how it affects the overall force. All right. Now, there's two things that Coulomb law knows about electrostatic forces. And electrostatic forces are forces between a positive and negative, or any two charged particles, or any particles with charge. The two things that determine how strong this force is are the amount, how much you got, and how far apart they are. So the amount of charge and the distance the charges are. That's the two things that will determine the electrostatic force. Much like distance and mass determine gravity, these two things will determine the electrostatic force, the amount of force between any particles with charge. Now, the amount of charge, how does that get affected? Well, well, the amount of charge, how is that going to affect the electrostatic force? Now, it's going to be attractive because these two have opposite charges. Is it going to be bigger or is it going to be less? Well, it's definitely going to be bigger. I held distance constant and the amount of attractive force went up. So, what's the relationship between the amount of charge and the electrostatic force? It's a directly proportional relationship, meaning that if I increase the charge, I'm going to increase the force of attraction or repulsion, and vice versa. If I decrease the charge, my force will decrease. Now, what about distance? Well, now I take the same two charges, all right, and I place one closer. These are closer. What's going to happen to the electrostatic force? It's like what happens when you bring two magnets closer and closer to each other? Well, as you know, they get more attractive. So the electrostatic force goes up. So this is an inverse relationship because I'm decreasing the distance and the force is going up. So that's an inverse relationship. One's going up, the other is going down. Or one's going down and the other's going up. Now, this is just a table for review. All right. The two variables that are in Coulomb's law for are distance and the amount. And distance has an inverse relationship. And that means as you go up, as distance goes up, the electric forces go down. And the amount of charge is direct. So they go up, the electro forces go up. All right. Now here's the equation. This little it's almost like a infinity sign where you've cut off one side is proportional. Your force is proportional to your charges and inversely proportional to your distance squared. All right. So the two charges multiplied divided by the distance squared. That's the equation. Now, and there are two things. When this becomes negative, that means attraction, and when it's positive, that means repulsion. And that is this video. Okay, let me know if there's any questions, and I hope you have a good day. Bye.